In lesson 22, we learned about sample spaces. Well, today we're going to be learning about experimental probability. So the first problem is Jada has a bag with tiles. She pulls a tile from the bag, records its shape, and then puts the tile back into the bag. She gets She gets a star 5 times, circle 3, and a square 2. Suppose Jada does the same experiment 100 times. What is a reasonable prediction for the number of times she'll get a tile with a star, circle, and a square? So how many times did she pull a tile out of the bag? Well, she pulled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. She pulled 10 tiles. Out of those 10 tiles, 5 of them had a star on them. So it has a 5 out of 10 chance of getting a star, or 1/2. Oh, I just skipped myself. So let me just restart. So she pulled 10 tiles out of the bag. 5 of those tiles were stars. So what's the fraction to represent the stars? So that'd be 5 out of 10, or 1/2. What's the fraction of the circles? That'd be 3 out of 10. And then for the squares, that'd be 2 out of 10, or 1/5. So if Jada pulls 100 tiles out of the bag, would you expect there to be more tiles with stars or squares? We would say stars, because there were more stars the first time around. Well, if Jada pulls 100 tiles out of the bag, how could you predict how many times you expect to be stars, circles, squares? We would set up a proportion. And we'll get more of that later in this lesson. Okay. So when you find the likelihood that an event will occur, you're finding the probability of each event. Each time Jada pulls a tile from the bag, she's conducting an experiment. In probability, the experiment is called a trial. The result of the trial is called an outcome. So Jada pulled a tile out of the bag 10 times, so she completed 10 trials. The outcome of each trial was a star, a circle, or a square. You can use the notion P outcome to represent the probability of getting an outcome. For example, write P star to represent the probability of getting a star. You can find the experimental probability of pulling each shape from the bag based on the outcome of Jada's experiment and the number of trials. Each probability is based on the results from Jada's experiment. If Jada repeats the experiment, she would likely, again, pull more stars than circles and squares. She may get a different number of stars, circles, and squares, but over a large number of trials, you would expect the ratio of stars in the samples to reflect the ratio of stars in the population. You can use this proportional relationship to predict the number of stars, circles, and squares if Jada pulls 100 tiles from the bag. Based on Jada's initial experiment, if she does the experiment 100 times, she should expect to pull out about 50 stars, 30 circles, and 20 squares, because you set up a proportion. So, on the reflect, it says Jada repeats the experiment 100 times. Do you think her results will exactly match your predictions? So it says exactly, not...
Second run to the front. Second run to the front, please.
So it's not exactly, because they're not, you don't know officially what's in the bag, but you would get something around the same thing, but not exactly. So read the problem below. So Luke rolls a number cube and records the results in the frequency table below. Based on the results, what's the probability of getting a 1, 2, 3, 4, and 5, and 6? Well, first thing you do is you figure out how many times he actually rolled the dice. So these are the numbers on the dice, and these are how many times he actually rolled it. So you're going to add them up. So 1 plus 1 is 2, plus 4 is 6, plus 2 is 8, plus 2 is 10. So he rolled it 10 times. Come on. So the probability of getting a 1 out of his experiment is 1 out of 10. So we'll say this 1/10. The probability of getting a 2 is, again, 1/10. The probability of getting a 3 is 4 out of 10. Because I'm looking at this frequency table. So the probability of getting a 4 is 0 out of 10. Probability of getting a 5 is 2 out of 10. And probably getting a 6 is 2 out of 10. So let's connect it. Look at the tally chart on the previous page. How many times did he roll the cube? He rolled it 10 times. So based on the experiment, what's the probability of getting it? Well, that's 1 out of 10, like we just said. 1 out of 10. And I can't see the table. So it's 4 out of 10. 0 out of 10, 2 out of 10, 2 out of 10. And you can simplify these. So we're not going to do a number cube. And then we're not going to do number 5. Okay. So a spinner is divided into 5 sections, lettered A to E. Kyle spins a pointer on the spinner 25 times. So this right here adds up to 25. He records his results in the frequency table. So based on the results, what's the probability the pointer lands on a D? Well, D landed 4 times. So that'll be 4 out of 25 chances. So the answer should be B. Okay. So what's the probability pointer landing on a vowel? Well, a vowel is A-E-I-O-U. So I have an A and I have an E. So I have a 6 and 3. So that's 9 out of 25 chances. So it's 9/25 is that one. Okay, next problem. Students in Luke's class combine the results of their experiment rolling a number cube. The results are shown in the table to the right. If the class repeats the experiment for a total of 1,000 trials, predict how many times each number will occur. And this will show you the probability of getting the 1s through 6s. But let's answer some questions first. So it says, use Luke's data to write and solve a proportion to predict the number of 1s rolled in 1,000. Well, first off, we have to figure out how many times he actually rolled it the first time. Well, if you add all these up, you get 200. So I have a 32 out of a 200 chance of getting the number 1. Well, let's say I've increased this to 1,000 times. So I want to set up a proportion. So 1,000 goes on the bottom and x goes on top. So then you're going to cross multiply. Well, x times 200 is just 200x. And 32 times 32 times 1,000 is just 32,000. So then you're going to divide by 200. This cancels out. X stays down here. The zeros cancel out. And you divide 2 into 3,200, which is, let's see, 160? Is 160. So I would expect the number 1 to appear 160 out of 1,000 times, okay, based upon my experiment already. So this answer would be 160. So determine the method you use to solve the proportion you wrote. I'm going to say cross multiply. All right, use the results from Luke's class to write and solve proportions to predict the results for the other numbers in the 1,000 trials. All right, well, I'm actually not going to solve them for you, but I will set them up. So the 2 appeared 33 times. So that's you're going to have a 33 out of 200 is equal to x over 1,000. And remember, you need to go back and solve these. The 3 appeared 34 times. So you're going to have 34 over 200 is equal to x over 1,000. The 4 appeared 32 times. So you have 32 over 200 is equal to x over 100. Excuse me, over x over 1,000. Then the 5s appear 34 out of the 200 times. So you're going to have equal to x over 1,000. And then finally, the 6s appear 35 times. So you're going to have 35 over 200, not 2,000, 200. Is equal to x over 100. Excuse me, x over 1,000. So remember, you got to go back and solve these to figure out the results for the predictions. So the class repeats the experiment with a total of only 25 trials this time. Well, predict how many times the number 4 will be rolled. Well, first off, the number 4 was rolled 32 out of 200 times. Well, let's say I do it again for another 25. So the 25 goes on the bottom and x goes on top. And again, you just solve and cross multiply. Okay, so the class repeats, another class rolled a number cube 100 times. So that means this adds up to 100. The results of the experiment are shown. The class repeats the experiment for a total of 1,000 trials. Predict how many times the number 4 will occur. Well, the 4 occurred 20 out of the 100 times. Well, I'm going to increase this to 1,000. So it'll be x. So a shortcut is I just went from 100 to 1,000. So I just multiply by 10. So I'm going to do 20 times 10, which is just 200. Okay, now it says predict how many times an odd number will appear for 10,000 trials. Well, 1, 3, and 5 are my odd numbers. Remember, this adds up to 100. So I got 15, 17, and 15. So 15 plus 15 is 30, plus 17 is 47. So I have a 47, I have a 100 chance, which I'm going to increase it to 10,000. So the way I increase it is I just multiply by 100. So I multiply the top by 100, which is this 4,700, which the answer is C. All right, that's it. The main idea is just setting up proportions again. Okay, and again, your homework is only what? 5 questions long. So watch this lesson. If you need help, just ask me or Mr. Tolleson. Okay, thank you guys.